Sharing it with us.
Sun Chase Apartments was extremely
I'm
upset.
so grateful.
Well, you know,
Thank you.
she said that she was smelling something. She says, "Honey, something is wrong." You'll hear her in the actual
It
video.
started weirdly.
Honey, there's something wrong. And I said, "Okay, go ahead and shut it down. Go ahead and shut it down." And she wanted to keep the ectone running for an extra minute.
For a moment, I'd like to just introduce Dr. Burisch, but before I do, I just wanted to reiterate what Dr. Awadi said, is that both Dan and I are retired from unacknowledged special access projects at various agencies within the United States government, including DIA, DARPA, NSA, and others. My background is in organization and musicology. Dan is a microbiologist, as many of you know. He's worked on biodefense programs from 1986 onward. As far as being a scientist, from his background in northern projects, he's very protocol driven. Dan tends to think outside the box quite a bit and back it up with precise analysis. He's actually more than willing to chuck an entire data set into the trash, and in short, that makes him a real joy to work with in the lab.
Thanks. Thank you.
Today what we would like to do is show you a little bit, create a brief overview for you about the research that we're doing up to date, a snapshot. We're looking for thoughts, ideas, and where we might go with it in the future. So ladies and gentlemen, let me please present Dr. Dan Burisch.
Thank you. We saw the phenomenon, and then after we recognized the phenomenon, we tried to make it go away. Not our words, the words of Dr. Jerry Hubbard from JPL in 1971, dealing with a peculiar silicate-associated phenomenon on the surface of Vicor when they were having some difficulties with anomalous organic formation on the surface of a pure silicate. As Stephen Jay Gould said, theories must have histories as well as essences. So we have been searching, hopefully not in vain, for the history involving this unusual phenomenon, which we have been tracking as a side project since 2001. Now that we're retired, we can put the largesse of our time to trying to pin down exactly what this phenomenon may be, what this phenomenon may mean to us. So without further ado,
ready?
What you're watching is, if I can see, okay, I can see it right here.
See it?
On the vertical and on the horizontal is a quartz crystal with no potential applied. It was bathed in salt water, saline, up to 45 parts per thousand. And now you see in live time the phenomenon which we call a portal. We've nicknamed it. We had to call it something, existing a couple microns above the surface of the quartz crystal. And now we're going to turn on, and you're going to watch a portal produced along the second axis. You have to actually see it produced to get a feeling of it. And there is the portal being produced along the surface of the vertical axis in a freeze frame. So we asked ourselves what this was. We originally saw something moving along the surface of a rock at the Frenchman Mountain Complex to the northeast of Las Vegas. Now, note to the upper right-hand side of the video, do you see the unusual prolate object and something seeming to be emitting from it? This shocked us. We said, what is this that's coming from this also unknown phenomenon? Could this item actually lead to something in our environment and affect it? Here is raw video showing the stream, as you can see from left to right, which appears like a dark band. This stream, this anomalous unknown pathway, is seemingly what is followed by what we have prudently called particles to their destinations. Again, we call them particles because we had to call them something. They're aggregate bundles of an unknown substance. Here you can see between 2 and 9 of the individual portals, and a stream coming from this pulsed laser. It doesn't matter if it's pulsed laser, it doesn't matter if it's continuous laser. Anything between 630 and 680 nanometers, the same sort of an object which Marcia here is using as a laser pen, will evoke the phenomenon with a trade-protected,
yes, absolutely,
a trade-protected optics train, which we will be patenting. And as I focus back, now you're seeing raw video here, you're seeing low-res video. We're going to get to the high-res stuff here in a second. What these articles are that are hovering transiently above the surface of any silicate, we don't know. We still don't know. We believe that they're possibly plasma, and we're going to be outlining the basic evidence to support that it's a possible plasma here in a moment. Now, 3 years prior to this circuit, a circuit which can be subdivided and then produces itself on both sides of the subdivision, something like an autocatalytic mechanism, if you take Fleischhacker's definition, was seen 3 years prior. And here you see in the natural coloration of the portals as they're handing substances back and forth. The white dots are the portals, and you can see them actually passing material back and forth, kind of like, well, what I remember the
Harlem
Globetrotters,
yeah.
with a magic circle, passing the ball back and forth.
Yeah.
Or we can go to Carl Wies's explanation that it's a soccer ball being passed back and forth in the same way that a horizontal gene transfer system may have worked at the time of the origins. So we knew that we were dealing with something special, we knew that we were dealing with something anomalous, and we began investigating further. Here you see the actual coloration with the red applied, the actual coloration of the phenomenon itself. Has anybody seen this before? Does anybody know what this is?
Anybody?
If you do, please let us know, because
Yes.
we would love to disconfirm this. Go ahead.
Okay.
I want to move on too, and this has been occupying now for 7 years. Thus far, we figured out 4 possible methods, 3 definite, 1 possible method for the evoking of this phenomenon. Change. Method number 1, in line with the optics train of a compound microscope with that laser pen, or that 630 nanometer laser pen, directed down through an optics train direct onto a crystal. You may say, are you looking at a flash of light? No, we're not looking at a flash of light, and we're going to show the difference in a moment. The second method is in line, actually orthogonal to the growth lines of a silicon dioxide or quartz crystal. Number 3. And finally, we have just taken the first steps now. Just taken the first steps to possibly confirming that this is a natural process. We have removed the laser. We've placed a sphere containing compressed carbon dioxide gas and a single biconvex lens in front of a reaction center containing montmorillonite, and we have evoked the phenomenon. Next. So we're asking ourselves next, and this is going to be carried out later this year, can this be produced in the sort of environment which is being prudently theorized by the great minds in science today as an area where the origins may have taken place, and possibly a mechanism which may have forwarded those origins. And as we proceed forward here, we're going to be laying out some evidence which may suggest that we're heading in that direction. Is it a flash of light? No. You see the incident light here striking the surface of the silicate, and you see the phenomenon now in a slightly higher resolution. We're going to get better with it. To the upper left. This here is approximately, if you're talking about the portal, approximately 20 microns across, and you can see that it contains many salient portions to its own anatomy. Mm-hmm. Please proceed. While looking at the portals, we first related the motion around the outside of the portal to the black discs that one may see at the bottom of a swimming pool,
or in your case, the bottom of a bathtub.
That's where I came up with the idea, truth. Which are called Snell's black discs. And these Snell's black discs occur because of a topological deformity in the surface of a fluid, in this case the surface of water. The motion around the center of these black disks reminded us of the motion of particles of detritus, of material in the medium, which were swirling about the portals as we were watching them live.
Next.
Please. Now here we're going to have a little close-up image of a portal under continuous stimulation. This is approximately here 20 microns across, again isolated and stabilized for motion. Now at the end of this little sequence, you see that little whip-like arm that's extending out? Right
There.
here you're going to see a whip-like arm right there.
It's quick.
That is right there. That is another image of an emission coming from this phenomenon.
There it is again.
Also, we've noticed that the portals seem to rotate above the surface, and we are theorizing that the rotation, and you can actually see the central feature, the central core of these as it moves and as it turns, that this rotation may actually be defined by the magnetic field which is evoked over the surface of the silicate substrate. Next, if you please.
There.
No matter how many times we do it, no matter how many times we run the propagation, there is a reproduced and there are conserved features in these portals. There's a central core which seems to flush outward. There is a region around that central core which seems to support the flushing outward, and there is an outer region of the portal. In the bottom right hand corner you see the same portal as in the bottom left hand corner, except for the bottom right has been imaged in the near infrared A band. It peaks well at 700 nanometers, which is the same general area, just below the same general area, is what Peter Garyov and Fritz Albert Popp have found for biophotons. So we've been asking ourselves whether this is a biologically active phenomenon as well. Please, next. The features of the internal structures of the portal are extremely turbulent. There are helical turbulences that we placed in negative along the right-hand side in the exterior portions, or the periphery of the portal, and there are even more turbulent areas near the central core. Now, we've blanked off the exact center of the central core because it just is basically a flash of light on our imagery. What that central core is and from whence that central core emanates, we don't know. We will be, of course, looking at it further and seeing what we can determine from it. Next, if you please. When the particles are emitted from the portals, there is a twisting, a helical twisting. It's as if they're spinning. It's spinning the particle outward and turning it almost like a screwball in baseball.
Frisbee.
Frisbee.
It's a frisbee.
Like a frisbee. And there appears to be a substance injected into the particles from the exterior portion of the portal. Now, I'm not saying from the core, from the exterior portion, because that's the only place that we have seen any salient activity occur involving the particles. If you look in the upper left, right here, you're going to see a central feature here. This is going to become important in a few minutes when we talk about Ochoa Pacheco's work.
Ready?
Next. Here, as close as what we can bring it, and being very reminiscent of Scott's work involving plasmas and how they can mimic bilipid membranes, we see a particle on the right-hand side being ejected out of the exterior portion of a portal. And you'll notice that there is a construction to the tube from whence it emanates. This told us that we're dealing with a highly organized phenomenon of some type. What is organizing this phenomenon is unknown at this time. Next. Now, what you're going to be watching here is some very fast video of a Class A particle, so-called Ganesh particle, absorbing, landing onto the surface of Cladophora glomerata, which is a type of green algae. It's a multicellular green algae. Those were single-second images, and you saw how it changed. It actually invaginates, turns into multiple cells which appear to be aberrant eukaryotic cells, and spreads to produce a cross bridge. Now, here is the cross bridge for the first time for the public. This is raw video of me nearly panicking over the compound microscope because I was trying to figure out what the heck this was that we were looking at. I thought we had to be able to key this out. It has to be just a nematode or some other parasite which was extant in an otherwise axenic culture.
This thing right here.
And I wondered how it could be present in an axenic culture because nothing else should have been.
There it is right there.
We find that these cross bridges are produced from a division of the particle. The cross bridge, when we try to isolate it, it goes through its own quick apoptosis, it lyses, dumps into the medium, and we have picked up very little in the medium, save during controlled experiments inside the Nevada test site. This is, of course, before the project was booted out of the Nevada test site. Now, what you're seeing here, this border area, is an actual impingement past the cell wall, through the periplasmic space, and into the plasmalemma of the Cladophora. It actually extends into, a pelus-like article extends into the nucleus. And here I was imaging it, asking myself if I was really seeing what I thought I was seeing. And that's why we put the raw video in here, is just to show you what it was really like when the first discovery was made. At the end of its phase, whatever its phase was, it appeared to slough off from one side of the Cladophora, from the primary cell. It extended between one cell and another cell from another trichome. And we are theorizing that it is possibly using the other trichome as a reservoir, as a library, a template, if you will. Which leads us to the question, template for what? Well, when we nick a cell and then we place it under this propagation, the particles which target this cell which has been nicked or injured absorb onto the cell and actually cause a reparative function to initiate. This reparative function we're going to get to in a few moments as to what the actual pathway may be. We're theorizing an RNA-type interference and a retroviral pathway. And that was the last we saw of the cross bridge as it was dumping into the environment. Now, here's an inference that we're drawing from this. We have stock images of Cladophora on the left and right, and you'll see data in black and white. The data is the real McCoy. And here is the growth, which actually extended, and we have a pieced together series here, from one cell to another, of another cross bridge.
Essentially from an injured to a whole.
Injured to a healthy.
A healthy.
And as the process continues, its life cycle, if you will, it gradually sloughs off, leaving two
healthy cells.
Cladophora cells, or trichomes. Next, if you please. While these particles enter into the vicinity of the Cladophora, they orient and they precisely move with respect to the surface upon which they absorb. When they gain within a 1 or 2 micron distance of the Cladophora surface, a flower-like item, an operculum, opens. Now, this looked to me like didinium. However, this is approximately 5 microns in length, from left to right, on image number 3, which tells me it's too small for didinium. So I thought maybe I was dealing with some other type of protozoan. Unfortunately, or fortunately, depending upon how one may look at it, we have higher resolution images of these particles coming, and it was not a didinium, it was not a protozoan, as we thought that it may be.
Ready?
Next, if you please. Here is an isolation of the material actually being injected into and through a artificial nuclear pore, which was opened on the target nucleus of the Cladophora, on the primary cell. These were taken from the actual data. This material then told us that we were dealing with something that was being added to the cell. What that was, we continued to wonder, and so we requested, I requested that some virology would be done, and we would gel out and plate out what might be added. Please. Here's what we found. First of all, we're going to talk about the individual cells, the Saccharomyces cerevisiae cells with which we worked. That's in this case, a diploid yeast. As time passed over an 8-hour period after exposure, we found that there was a 14 times increase during tests of available protein in the medium surrounding the yeast once they were jiggled and relysed. This is heat-fixed yeast. Heat-fixed meaning
heat.
dead.
It's dead. It's been heat-fixed on a slide.
Onto a slide. We also ran tests for reducing sugars, such as glucose, fructose, and also ribonucleic acid and deoxyribose. We also tested for phosphate and ammonium because of their integral portions of DNA and RNA. And then I decided to do a quick methylene blue smash and grab test. And what that was a way of actually quickly removing the DNA out of the lysed cell. And we found that there was a significant difference chromographically between the tests and the controls. Please. In the case of Cladophora glomerata, we did interruptions. We allowed the Ganesh particle to absorb onto the surface of the Cladophora and begin to impinge the plasma lemma, and then we disrupted it and lysed the cells and began testing. What we tested for was whether or not we could detect any nucleic acids, and boy did we. We detected a double-stranded RNA and an extremely short base pair RNA, which told me that we were possibly dealing with a microRNA. If we were dealing with a microRNA, what kind of a microRNA? Then we looked and we found that we had the methylguanosine 5 cap and the 3-poly A tail, which told me that we were dealing with something that had been processed. In other words, some sort of eukaryotic process had been applied to this to cap for protection and to add the polyadenal tail for the translation process. The polyadenal tail basically makes a determination as to how long something will reside in its process in a cell. We also found catalytic cores, C-terminals, and integrase components along with probable positive sense messenger RNA. And at that point I said, aha, we're dealing with a retrovirus of some kind. And a retrovirus that was working with a double-stranded short microRNA. A double-stranded short microRNA could be an interference RNA, which means it could have entered into the cell, shut something off, which then allowed the integrase components to reverse transcriptase the RNA into the cell. For what purpose? We still didn't know, and we still don't know, aside from the fact that we're getting reparations. And here's a quick histogram showing a right shift for the tests from that smash and grab that we did on the Saccharomyces cerevisiae. In every case, we had a substantial addition of something. And we knew that now that that something is some sort of an RNA component. Class B particles, what we call Class B particles, these are the things which are being carried by the Class A particles that we've learned. Now, take a close look at these. These are imaged from a compound microscope, a light microscope. What are we dealing with here that we should find something that looks like stock images of viruses? These are way too large. And they look like, well, you can see the upper two, they look like a bacteriophage. I've got a T4 bacteriophage.
Right there. And this is
down at the bottom on the bottom left, we removed items in isolation from the exterior portion of one of these Class B particles, and it looks like a penton fiber. And on the bottom right, you'll see the two images, which are stock images, not from a light microscope, but from a transmission electron microscope. And I was using 100x oil for what we imaged. So in other words, they're way too large, or there's something going on with the optical properties around this, this phenomenon, which is causing a secondary magnification. Royal Raymond Rife? Maybe. I don't know. We're looking inside of a cross bridge now. And you can clearly see from the left to the right a difference. Right here and right here. Now, here, and now over to the one on the right. These Class B particles are coming in and they're attaching almost like you would see a diagram of attachment during dehydration synthesis for a polypeptide. And then they move on. They move on between the target cell, the primary target cell, and the cell to which it attached, the probable normal cell. Next. Can we prove that something is being added? Yes.
Yes.
This is what led us toward it. Green fluorescent protein over 8 hours. This is this 8-hour addition that I was talking about. Green fluorescent protein analysis caught by accident at the corner of one of our cinematographs. Look at the additions. Why is it getting thicker? Now, what you see here is you see an actual injection into the center of a heat-fixed Saccharomyces cerevisiae cell. The object on the far left is the so-called Ganesh particle, a Class A particle. The object inside the gap is a Class C particle, which we will get to, a possible acoustic responding particle. And here's the video. And we have an injection, and we have a dropping of material. Second injection, first injection, and again, a dropping of material. So we asked ourselves at this point, because this was actually before we got the results of the double-stranded RNA in the positive sense, messenger RNA, we asked ourselves if something was being injected here, because obviously because of the magnification, we're looking at quaternary structures. What the heck is this that's being added to these cells? And I apologize for the fact that these are out of order in sequence in time, but that's how it was actually found. So we're trying to give you a sense of the almost backward feeling as we've been wandering forward into this. Class Cs. We use the name biomorphoton from William Hamilton. It was a play on biophoton. We've actually tracked and have video, and we only, again, have so much time here today, but we're going to do expansive videos for the public coming up, showing the biomorphotons, or these unusual anomalous objects, swirling around the particles and changing their shape, or at least being in the presence of the shape while it changes. So there is an active secondary process, aside from the fact that there is an anomalous plasma phenomenon. Next. We have conserved and reproduced structures. We have unusual structures for which we have no idea what their use may be. And we also have something that appears suspiciously, and you're seeing two different ones there, appears suspiciously in it as antennae. So we asked ourselves, antennae, is there radio waves? Well, she spoke over the top of a compound microscope, and when she spoke over the top of it, we watched the behavior of this type of particle change. Please, next. Another variety of the same type of Class C. They appear cube-like. They extend out into long rectangular solids, and they collapse into almost hexahedra. Next. And what I consider the most beautiful aspect of the phenomenon, the Class C that looks like a flaming torch. Here you see it actually absorbed onto a eukaryote, and on the right you see the false coloration. Now we're going to get to this in a moment. Note at the base of this structure, which Marcia nicknamed selkies, an unusual object seemingly popped up through the skirt of this object. And this gives us the first clue. This image gave us the first clue what these particles may actually be. They may be enclosed microshards of quartz. We have David Wilcock here, who's going to speak just for a moment about Ignacio Pacheco and a possible independent confirmation of the so-called Ganesh particles. Now, if you look on the left-hand side, look inside the operculum. Remember I said take a look at that structure as it was being whipped out in a helical fashion? There it is in an independent study. David.
The key to all good science is replicability. It's important when you look at data such as Dan's to understand that there are correlations that have been found in independent studies that had no relationship with what Dan has been working on. These are public domain, they're not from secret projects. In this case, we're dealing with Professor Ignacio Pacheco, who's from South America, and what he did is to take beach sand and heat it with a torch to white-hot luminescence, at which temperature there is a complete killing off of any life form that could ever exist. However, he was then able to take a sterilized test tube with distilled water. This was all done in a vacuum, so there's no possible way that there could have been any life forms in that medium. He then inserted the beach sand into the test tube after it had been cooled down in distilled water, caps it off, and then simply allows the test tube to sit there for a while, at which time it forms a surface layer on the top called a surfactant. The surfactant was then extracted and studied under a microscope, and what we found was that these little guys were growing inside the surfactant from an utterly and completely sterilized environment, which means you do not need the optic train method that Dan is using. The value of Dan's research is that we're seeing on a microscopic level the actual processes involved in this life coming out.
Thank you,
David.
so much.
David brought this independent confirmation of the research to us, and it was a total shock to me. Now, this, of course, is associated with some of the research work involving Wilhelm Reich, and we are not associated whatsoever with the Orgone Foundation or anything like that. But we are, of course, interested in the independent confirmations of at least the morphologies of the particles. Next, if you please.
Over to the left is old Las Vegas, Fremont Street. The area to the right is Nellis Air Force Base. This is the Vishnu Schist Rock. The project that Dan is working on started in this area. Here you see Dan and his wife Deborah doing their work. We will try and retrace their steps. The granite running through this rock is kind of interesting. It's 1.7 billion years old, that is billion. This vein runs through this mountain for almost 1 mile. There are other areas where it is exposed. We will have to do a little more walking at various areas where the vein is accessible. This rock has been created by intense heat and pressure over the millennia. But the interesting thing about it is, from where I stand, at least Dan's research seems to imply that within this rock millions of years ago, humanity, or the human race, was seeded, scientifically called panspermia. We have come from outer space at a molecular level. Somehow, in the great universe, has inculcated themselves into this Vishnu schist. That is what they are doing, plus a lot of other exotic research.
Now, in walks Humanawati. He suggested applying a very small neodymium iron boron magnet to see whether or not the portals would orient under magnetic influence. So we initiated the propagation, and we got our portals out on the surface, live out at the Frenchman Mountain. And there is raw video of what it looked like. So we began isolations and using threshold, and found that we had our portals produced, and then we came in on the areas, of course, and began doing higher resolution images. And now, ladies and gentlemen, what a single portal actually looks like under high resolution functioning.
Yeah. Wow. Yeah.
What was cool about this was that, in fact, and we will show you in a moment, they began orienting to the magnetic field. This is a peculiar property of plasmas. And here we are, seriously slowed down. You're going to notice in the upper right-hand corner, material being injected off to the upper right. And you'll see also what appears to be material ejected to the upper left and the bottom right. The upper left and the bottom right is a function of the sloughing off of material as the portal is spinning. Now, we had to work a little bit to get this motion stabilized because we were working in a condition where there was ambient wind.
Right, it was a field experiment.
Right, so they actually, she did it with her JVC camera that's filming us right now.
Right,
that same camera was the one which was actually used about 30 centimeters away to film this.
Yes, we actually went up on the ridge at Frenchman Mountain. We found a local piece of rock that fit the description we needed. We set up the camera and allowed it to run using Dr. Owadi's suggested methodology.
Right, I had to just every few seconds rotate the magnet about the reaction center where we were causing the propagation. And what we actually used, I think you may have seen it, what we actually used was the tray carrier from the inside of a microwave with a clamp on it. Hey, it worked. Now, when this gets to you can see the particles actually being emitted. We're going to do a backlighting for you to see the particle actually fire and leave. Now, what happens just prior to the particles firing and being emitted from the phenomenon is that there's a coalescence of material in the outer portion of the portal. And in the upper right there, you see a particle actually firing. Boom.
Boom. Watch about
Boom.
there.
And there is our isolation of the particle actually leaving. Now, if you look very closely at the start of the sequence, you'll see that the greenish yellow material in the outer periphery of the portal coalesces until finally the particle fires. We called those biomorphotons in the same way as what we prudently called them for the Class C particles. Now, here you're going to see the actual eruption of a particle from the surface of a portal. And there's a high-resolution picture of the Ganesh particle. And an explosion and a settling, they rotate, and then they're swung out into the environment. And the best that we can say at this moment is that they are aggregate bundles of an unknown material. However, Marcia suggested that they looked like cotton candy being wrapped.
Cotton candy wrapped on a stick at a county fair. The stick being a microshard of crystal.
And there's about a 40-degree difference between the relative axes of motion as the particle is wrapped and sent out and the rotation of the plasma itself. We did a number of waiting time window counts, and with those waiting time window counts, we found that there was a aperiodicity with a waiting time. Human immediately said, Poisson distribution. Did you not?
Yes, you did.
I thought that I saw a periodicity. If you're looking at the graphs on the bottom left, it appeared almost like a heartbeat, but there was actually no periodicity to be found. So we may be dealing with a stochastic process. It may be random. However, that randomness carries out fairly evenly all the way from 2004 through the 2007 data. It doesn't matter if we're dealing with continuous laser, pulse laser, it still seems to range every 1 to 1.2 seconds. There's a firing of a particle out of the portal. And here's the orientations under magnetic field. You can see that the particles actually emit orthogonally to the direction of rotation of the portals. And the portals, unless they're being disrupted by ambient wind, which they were in some cases, or they're organizing or disorganizing through a process which we're not exactly sure, they orient very nicely, very precisely under magnetic influence. Next. Also, on the upper left, you see 2004. That's about 20 microns across. Upper left, 2007, is approximately a millimeter across. If we look at the so-called biomorphotons, or these objects in the outer periphery, on the upper left, or well, it's the upper right segment. It's the upper right segment of there.
Okay.
We'll notice that the size of these objects in the outer periphery remain constant to the overall size of the portal. That tells us one more piece of evidence that we are having a highly organized phenomenon. Next. Here you see the actual coalescence, the bottom portion of the image, the actual coalescence of material in the outer regions of the portal, and ultimately it coalesces and it fires the particle into the environment. We ran a truncated cone test. We put together a rudimentary test to attempt to identify what the content, what the chemical content of the portals may be. And so what we did is we isolated a crystal point from a geode and fired a laser level laser through the optics train and into a truncated cone. In other words, we used a lampshade and I cut a hole in it. Next. And what we did is we fired the laser from right to left through the point to elicit the phenomenon, and we actually have on the left side of the image there you can see where there is a mirror located and a targeting point. And in fact we received a refraction. We were grateful that it was a positive refraction rather than a negative refraction, that we were not dealing with a metamaterial here. We were dealing with something which was as prosaic as what it gets. And we refracted off to the right, next, finding on the right side of this image a refractive index of approximately 1.039 after several trials. That refractive index is consistent with polystyrene, and it's also consistent with E. coli bacteria. So are we dealing with a polypeptide of some sort here? Are we dealing with a bacterial-like substance, or at least a substance which contains the same refraction? At least the same refraction. On the left-hand side, you see data having to do with temperature. And this is upper left. We noticed when we evoke the phenomenon that the center of the reaction core is about 3 degrees Fahrenheit warmer than the area surrounding it. This tells us that we have something extremely, I guess we would call extremely strange, going on with the phenomenon. What we did here on the surface of Montmorillonite, if you see in the upper right-hand corner, you're seeing the actual reaction center which was tested for that temperature. And this was Montmorillonite under natural sunlight. We evoked the phenomenon, and if you noticed in the bottom center, on the bottom center right, you'll see from the April 24, 2007 test that Human suggested. On the bottom center left, you see the whip-like arm from the natural propagation. So again, we have a replication of the phenomenon. Next. This is what excited us. Center you see, and center right, you see a portal functioning. And you see the central core functioning, wobbling inward, wobbling outward. And after the propagation was concluded, I looked at the surface of the Montmorillonite and found those rosettes on the bottom right-hand corner. That told us, ladies and gentlemen, that if this is a natural process, it happens in nature, perhaps happened over geologic time, that we ought to be able to go into the field, dig, and find it. What's the history of this? Again, they must have histories as well as essences. James Ferris has been working with Montmorillonite to catalyze RNA strands. We know that they naturally catalyze in the 2,1 smectite. It's a alumina silica type bilayer, tri-layer actually. And they are easily connected because of the tensional forces between the layers. They kind of suspend using the negative phosphates between the positive surfaces. And in so doing, RNA can actually naturally extend itself. Next. And by goodness, just like Jerry Hubbard said, he tried to make this phenomena go away in 1971. Who was there at this same meeting of the luminaries, including Dr. Carl Sagan, Barjorn from Harvard, Lynn Margulis? Who was there but Dr. Ferris at the same meeting of the 4th meeting for the origin of life, chemistry, and radio astronomy. And in fact, he said we should look at the unusual energies involved with this. And Lynn Margulis said, let's look at the Vicor. Perhaps it's the silica that's causing this. His interest has stayed for a long while, has it not? Next. 350 million year old hydrothermal vents show like compartments. The botryoids is what we are finding as possible either paleoignite or neoignite or pseudofossils, trace fossils from the Lotus phenomenon. Next. So we went out digging again. We ought to be able to find it if it's out there, right? We ought to be able to find it in the geologic history. And so what we did is we pulled a Cambrian rock out of the Cambrian seafloor bed, and look what we found next. Like rosettes. Obviously, we have to get many more replications of this. We have to get a large data set built before we can say this was from that. And we have to do one more thing. Next, if you please. We have to be able to say that we see it happening now. If it happened then, I know it was a reducing environment, now it's an oxidative environment, but if it happened then, it ought to be happening now, especially since we're seeing it happen now under controlled conditions. This is a Pennsylvanian era stromatolite, wherein inside of the cycad-like structures we found like rosettes. We have to have a stromatolite expert look at this. This is part of, it's an ongoing process. We are in the middle of a piece of work. We're not certain yet as to whether or not this is a conformation inside the stromatolite, but it may very well be. Next. Histories as well as essences. We have prudent determinations that life may have originated by impact sites, it may have originated at geothermal areas, it could have originated near volcanoes, it could have originated at the deep sea in 400 degree Celsius vents, it could have originated in a number of places, but where is the unifying event? Next. Bottom left, we have the supposition of a low temperature reactor, which has been published. This low temperature reactor produces, among other things, expansions of clay silicates, and it also produces the salient features for what's called the thioester world. It's an RNA-based, thioester-based world, which has been proposed by people like Duvet and also Leslie Orgel, who passed this last October, I understand. The results that we have show that there is an increase in the various type of enzymes which support the same mechanism that we know are involved in the low temperature hydrothermal reactors. We have carbon monoxide dehydrogenase upregulation. We have acetyl-CoA synthase upregulation. We have acyl transfer RNA synthetase upregulation. All of these items which, together with the production of RNA, may have resulted in the first cells. Additionally, we have these things called transposable elements. And they're really movable features inside of the eukaryotic genome. What you see with the green bar from Kunin and Galperin is a high correlation between the genome size and the size of the coding portion of the genome. That portion of the genome which actually produces protein. And that high correlation exists in bacteria and what has been proposed as the more ancient archaea. However, look at those dots up to the upper right. As soon as we get to eukaryotes, the genome size, the C+ paradox, grows proportionately large to the coding size. So we're picking up extra baggage from somewhere. we may see who the porter is here for that extra baggage delivering processes to the cells. On the right-hand side of this image is basement material from underneath Lecanora, which is a type of lichen, a crustose lichen, removed off the surface of more of the potassium-bearing feldspar at Frenchman Mountain. When we separated the basement very carefully, microlayer by microlayer, we found the rosettes from lotus. Or at least we believe they're from lotus. But what we have to do is we have to actually watch it happen first without interfering by the use of our optics train. But we are starting to learn for the first time where to look. If we find where to look, we may find the actual material.
June 21st, 2003. Dan and his wife, Deb, were present, and I was observing remotely from a camera angle as a propagation was underway using a tone. Actually, it turned out to be an F tone.
That was the explosion she saw.
To perturb the experimental paradigm. What happened during that, as you can see from here, there's a rather nasty burned area. That was the microscope.
It was the area around it.
The microscope melted.
I used a crystal this size.
The crystal was about that big. It was being, Deborah is on the right. She actually was burned in this.
She lost her eyebrows over that one. I was laying on the floor at the time.
Dan hit the floor. The head of the microscope blew off and embedded itself into the acoustic ceiling tiles. Now, all of this happened.
The apartment was very unhappy with me.
Yes, they were. All of this happened with extremely small input of energy, extremely small input of light, of electrical energy, and it had a disproportionately large result. This is one of the reasons that we are keeping the high-profile optics train under wraps, because we really do not want to move this research forward toward a weapon. We want to move this research forward toward helping people. And it would be... You
have our word of honor. We've called this the lotus. This flower shall remain peaceful.
Peaceful. So we have decided to restrict the optics train. How do we know it was triggered acoustically? Well, we have not perturbed it in that manner since.
Wife wouldn't let me anyway.
Oh no. We did not perturb it in that manner beforehand. We made small perturbations with sound, acoustic sound, after we discovered, when I was leaning over the microscope, that when I spoke, that the Class C particles, the Selkies as I nicknamed them, actually had movement. And it was related to the acoustic vibrations of my voice. So we made some small tests. But in this case, the case where you saw the explosion, the F tone was held too long. It was not abated quickly enough. It was not abated upon request. And it abated itself.
If you go to Google and you look for a dangerous lotus,
yeah,
you'll actually see the sequence. We uploaded it to Google. You'll see the sequence, and you'll actually hear the wife and myself speaking as things were going wrong right prior to the explosion.
When the explosion happened, what I saw was an amorphous mass of light. It started to fill the screen that I was looking at. Shadows became extremely sharp, black and white almost. It was just phenomenally bright, and then all of a sudden there was this crack. The camera that I was looking through was fried. All of the security cameras were fried. I received a phone call from security, and they said, we're going in to check on them, because they didn't know if anybody had been injured. In fact, Debbie was injured.
It probably serves those assembled to know her statement of security cameras. The folks for whom I worked actually had security cameras in my residence while I was in their employ.
Yes. So when they contacted me, they had actually reinstalled some temporary cameras, which is how they were able to, how I was able to get images of the melted scope. This slide shows several aspects of the portals that we have been researching.
As they're rotating.
As they're rotating. What we've noticed is their behavior tends to match acoustic models of water droplets that are rotating and vibrating. I may have to turn this up.
This is the this is the standard slide.
Okay.
They're going to hear what the portals sound like in a moment.
The portals have an associated sound. There's about a 20-minute gap. What happened was we decided to try to ascertain if the portals created sound. I mean, we realized that the Selkies were responding to sound. We wondered if the portals were creating sound. So what we did is we created a chamber, a baffled chamber with open cell polyurethane acoustical foam and basic commercially available microphones and digital multiplexing systems. We found that there was a sound that was created about 20 minutes after the initial experimental run began, at about the time when the portals formed. There's two phases to the sound. One is a rumble, and one is song-like. This is the... That's the first sound as the portals are firing and opening.
It's the organization phase. And then you'll hear a ring. That's a machine noise, and it's been stitched together several, so you can get a feeling of what it actually sounds like. It doesn't last long.
No, we had to stitch it together so you get a sense of it.
It almost sounds like a chorus.
Like an ah sound in there. Oops.
That even sounded better.
That we didn't need. This image is showing the external area of a portal. Now if you notice up in the upper left section there, you see what look like small gems. Those are actually micro shards of crystal that appear to be embedded in the exterior portion of a portal. What makes this important is that we've discovered that up the skirt of one of the Selkie particles, we were able to determine there's a characteristic of quartz crystal evident. This is, like I said, for the stick for the cotton candy. There are other types of Selkie particles that have 4 pillars of crystal. These are the ones that tend to collapse into forms that resemble platonic as well as Archimedean solid forms. This is a Selkie under short duration perturbation with an F note. You can see that there is a little dance going on here.
That's as the F note is playing.
It's playing.
Can you turn we should have sound.
I don't know if there's sound on this one.
Yeah, there should be sound with this.
There should be. This is backlit. A slightly different version of it. But you can see the movement.
Boom.
Boom.
That's as the F note is turned on. So we know they are reacting. And dynamically reacting.
Again,
This is the so-called antenna area.
this is a portion that we've nicknamed the antenna because we really don't know what it is, but it looks like an antenna. We reasoned that it could be theoretically possible that there was an acoustical component of this reaction that may be being received by the Class C particles.
The Class C particles arrive to the cells first before the Class A's arrive. So we have hypothesized that they are possibly acting as what would a crossing guard. They act as beacons. And here's high resolution time passage showing their reaction to the F node.
At this point, it's still theoretical. We haven't done enough runs to come up with a solid theory. But this is where our research is leading us at this point. You can see the dance-like movement of the lower portion as it fans out and fans back in, fans out and in. Couple that with the sounds coming out of the portal area, we begin to think that there may be some type of a
before and after, before and after.
Before and after. Information or communication phase.
Why is it reacting? There's a possibility that there's more than one shard actually composing this particle, whereas there was only one shard in the one that looked like the stick figure.
Whoa, turn that down.
That sounded good.
Yeah, it sounded lovely. So as a recap, we have areas of the Selkie particles which appear as antennas. We have Selkie particles which appear as platonic as well as Archimedean solid forms. We have theorized and we are currently investigating the potential for sound to create form and therefore possibly have an impact upon the particle distribution and activity. Dan, turn it back to you.
So far, this is what we've learned. We've learned that a phenomenon can be evoked, which is possibly plasma, probably plasma, definitely anomalous, and that this phenomenon interacts with eukaryotic cells in our environment and deposits material into those eukaryotic cells which are possibly of an RNA interference type pathway and definitely of a retroviral or at least a possible transduction-like pathway. Where we're going from here is, in fact, we spoke with Human. We were planning on rerunning the Cladophora glomerata data again ourselves, because they were willing from the Nevada test site to provide us with the results, but they were not willing to provide us with the gels and the actual images, the chromographic as well as the X-ray imagery which was done from the gels. So we need to know that, and we need to know what the sequences are, what primers they were using even. And they're not willing to give that up thus far. So being that we're retired, as soon as declassification occurs, you're gone. So what we're going to do is we're going to rerun it, and we will republish it, make it available. I would think that we're going to get the same results, but we will find out. These folks from all over the world have sent in samples to us on the right-hand side. Sent samples of sand from about every beach on Earth.
On Earth.
Again, we'd like to thank Dr. Awadi for the time here today. And David Wilcock, of course. David, thank you.
Thank you.
And one of our closest friends, Ron Garner, and whomever they may be, the members of the think tank. Ladies and gentlemen, thank you.
Thank you.
Joshua, tag, you're it. Private message. Oh, please.
Questions? In your experiment with the heat-fixed yeast cells, are you positing that the genetic material is not only inserted, but that these dead cells were restarted somehow?
Not only were they restarted, we actually ran out of presentation space. We have some images of what those cells actually look like. Serious anomalies presented. Such serious anomalies that the type of cells which we originally heat fixed were not what we ended up with at the end.
What number?
It is number As soon as we noticed that an anomalous cell proceeded, there's the Poisson distribution I was talking about, we didn't get enough time to show. There we are. Here we have a disorganized nucleus, and these what we think are tetramerized heterochiral DNA, which was ultimately provoked by the Lotus phenomenon, lack of a better term, and over a several hour period, the same nucleus, and you can see where the actual attachment of the DNA was to the newly formed nucleus. Next. This is what resulted from the Saccharomyces cerevisiae cell. By no standard is this normal. It appears to be a polytene-like chromosome arrangement out near the exterior cytoplasm area. There did not appear to be a normal aggregation, and there was certainly, I'm used to dealing with nuclear to cytoplasmic ratios, and that was nothing like it. Once we noticed what resulted, it went to the sodium hypochlorite. Bye-bye. And the reason being is we didn't know what we were bringing into an uncontrolled environment. We're not working in a cabinet lab, and this would have required at least a biological containment lab 3 or above. Additionally, we ran experiments involving the famous Spallanzani spontaneous generation decapitation, if you will, yes, where he superheated beef broth. And when that superheated beef broth was closed, he had no growth.
Right.
Well, we superheated the same type of beef broth, well, generally the same kind, except for we had a silicon dioxide crystal stuck in the bottom of the chamber, and we propagated Lotus through it. That's what we got. Now, this is suspiciously, extremely suspiciously, like neuronal arrangement, like interneuron arrangement. And that went to the sodium hypochlorite as well.
Rapidly.
I
understand.
Good Lord. We ran it at 2 separate locations, one under her control and one under mine, and very early one morning after I was looking at the initial results, she heard me banging, not knocking, banging on her door to kill whatever was in the tubes.
Mm-hmm. Absolutely.
So what we received was an anomalous response, an unknown cell formation, and one that we were not willing to bring to sentience. Not our place. Yes?
I saw both of your talks at Laughlin, and this concept of these cells being regenerated in some way reminded me of something that was talked about in the conference that I saw, where plants that were genetically deficient and injured were healing.
That was my presentation. Correct.
Could you explain that too?
Okay. There's a wide variety of data which supports the notion that there is an intrinsic consciousness field which has properties associated normally with living systems, but which is essentially an implicit energy field underneath electromagnetic energy. There's a great deal more research into this from Russia than there is in the US. However, it is a statistically documented fact that over the last 35, 40 years, there's a plant which is used in biological experiments in laboratories all over the country. This is a standard laboratory plant, and what happens is that when you relieve the plant of the DNA information that would allow it to normally form, you get mutations, and that's the normal expected result. If you tinker with the DNA and you take out some of it, then you get these mutations. What they have found, many scientists, and it was finally admitted to a few years ago, is that over all these experiments, no matter what they possibly do, about 15 to 20% of these plants spontaneously heal their own genetic material. This has also been determined with the fruit fly Drosophila, same thing. You remove the gene that forms the eyes of the fruit fly, no matter what you do, after 5 generations, the eyes return. And so this benefits us insofar as these genetically modified crops will never have terminator seeds. They will always be able to regenerate, because if you have the existing genetic material, this intrinsic field seems to be able to recouple the DNA to its original formation.
What we're theorizing from the data is that we're having a P53-like homolog response in the green algae. That is considered the master control gene for the cell. It provides a genomic stability to the eukaryote. What it does is it's a checkpoint, and it either stops the synthesis of the DNA from it going to that portion of the cell cycle to synthesize DNA, or it sends the cell off into what's called an apoptotic pathway, in other words, cell death. And it's both of those features which add to genomic stability. If it was not for that, we would have runaways such as cancer. If there is a mutation in the P53, we get cancers. The function, the meaning of the homolog, while it has not been found, a P53, exact P53 gene or TP53 protein in green algae, the work by Niddleque from New Brunswick a few years ago indicated that the algae respond in the same way under stresses, which would normally be induced by a P53-like pathway, and therefore it was prudently believed to be a P53 homolog. Now what this P53 really does, it's hooked to something called MDM2, and there are chemicals, enzymes, which cause it to be unhooked. Check 1, check 2 in ATM. And if it is not unhooked from it, it's carried out of the nucleus, out into the cytoplasm, and it undergoes ubiquitin in the proteasome, and it's destroyed. But if it's separated from it, it actually imports the activity of another enzyme called PIN1, and it changes its shape. It's all about shape. And as it works the PIN1, it changes its shape so it cannot be rebound to the MDM2. After that, it then recruits another series of enzymes. It's a complicated matter. And it produces, it upregulates, if you will, the activity of another protein called P21. That P21 hooks to a couple different complexes, cyclin kinases. And what that does is it causes a short-circuiting of the cell cycle just for a while. As it short-circuits it just for a while, that allows the cell time. There's a whole series of other cascade of reparative pathways that then undergo or are upregulated to repair the mutations in the DNA. And that is what we believe that we're looking at actually with the lotus phenomenon. Now, implicit consciousness field, I won't stand here in front of the public and lie. Yes, there are aspects to the research which indicate that we are dealing with something much more than the prosaic. And we're attempting to narrow those items down and present those items in the appropriate environment. For our purposes here, of course, today, we're dealing with the empirical. I saw a hand raised just in back of you first.
Yes, how can this stuff be used for peaceful means? I'm very interested in that. It's very exciting.
Sure. Well, the first thing we can do is not release the method to cause this. I worked in the biodefense industry, and we built several things which could ultimately be used for wrong. I was in the defensive end of it to try to short circuit some things some bad people were doing back in early 1991. The storm in 91 in Iraq. That's the first thing we can do.
Can you repeat that last thing?
Desert Storm in Iraq. That's the first thing we can do. The second thing we can do is this. We're going to be requesting from the public again more samples, help. We want more beach sand from all over the world, and we're planning on using that beach sand to produce a device. Patent the device, and then we have given our word, and we will be good for our word that once that device is patented, we will provide that device over to Dr. Awadi and CalTech for them to do with it what they may to confirm or disconfirm what we're looking at. But what we're planning on doing is this. You heard Marcia mention about the combination of the acoustics as well as the lotus phenomenon. We're going to be combining these two concepts. We're going to use several possibly arcane techniques to combine these two and attempt to bring a beneficial outcome. In a unit, initially we're going to work with some pulmonate snails. And we're going to begin that process second half of this year.
It may take several years for us to fine-tune and refine the process because we're going into uncharted territory with this.
And we're not going to allow something to be handed over to anyone, which can produce that. We're going to say that we just forgot how that was caused. Sir?
Is the term zero-point energy at all related to what you're doing here?
Oh boy.
Well, given the fact that we had an explosion that burned the wife's eyebrows off, and all we were using was a 9-volt battery at the time, a little bit of saline, and a penlight laser, I think that we may be dealing with something along that line. And Dr. Awadi was speaking with us earlier about a Kashmir oscillator.
Right.
Hooman, would you like to tell folks about the Kashmir oscillator? Because you know I am no engineer.
Okay, it's basically a very simple theory. 56 has been predicted force between two conductors at the nanoscale. This force is a result of the vacuum fluctuation field. 99 Pinto published a paper in Physical Review E, basically showing that if you can build this place at the nanoscale and have a thermodynamic cycle, where during this cycle we change the optical properties of your plates, then in theory you could plant energy from that vacuum field without violating the second principle of thermodynamics because your system is not isolated.
Thank you.
Thank you.
One more question because we're actually running out of time. Both of you doctors.
Both doctors.
I wanted to commend you for your research. I'm familiar with
Thank you.
Your drive, the Moscow group, on the DNA wave, and I think your great research is a step forward.
Thank you.
In the biophonic field of definition. Where
Thank
we
you,
go
sir.
from here is up to you and other researchers to push the envelope.
Thank you, sir.
Thank you.
Mine is pretty simple. The portal that emits this effluence, whatever, lack of a better term,
Yes, sir.
have you been able to isolate and or contain it?
Yes. In fact, the original, the first video that we put up, it was actually isolated and contained, but not isolated and contained and kept functioning. We can isolate its position, but we cannot sustain it indefinitely. In fact, that's why we moved from the continuous laser over to the pulse laser, because we find that there is an extinction. After about 10 to 15 minutes, once we evoke the phenomenon, there is an extinction of the phenomenon if we use continuous laser. So we went to pulse laser to actually cause the phenomenon to evoke and to recede, evoke and recede, so that we could study it for a longer period of time.
Ladies, if you have additional questions for us, we will be available outside this building. I have been informed that we have to leave now.
Yes.
We have a class. Thank you.
Thank you.
Thank you.
Dr. Roger Lear. I'm a specialist in diseases of the feet. I have a degree in podiatric medicine and a Bachelor of Science. I was interested in the presentation that Dr. Dan Burisch did at CalTech from several different standpoints, primarily being the scientific aspect of the presentation. And I was extremely impressed with his knowledge and the presentation that he gave in relation to a particle release called the Ganesh particle. I thought he was very articulate, and with the slide presentations showed material that certainly was scientifically new. I don't believe that anybody had heard this before, and it was quite astounding. Also, if the experimentation continues to the end that he wants to bring it to, it's going to revolutionize the theory of life on planets in our solar system and perhaps other solar systems in the universe.
I'm Dr. J.J. Hertog, founder and president of the Academy for Future Science. I was privileged to be a scientific observer at CalTech, listening to the presentation by Dr. Dan Burisch regarding his unique ontology regarding biogenesis and the forces responsible for the creation, basically, of the DNA process of life. What I found interesting, and I completely agree with, is his assumption that there is electromagnetic carrier frequencies or electromagnetic packages that are floating upon a less dense river of magnetism responsible for the triggering mechanisms of life and the unique packaging of the DNA process. Also, I find interesting that if you look at the greater design of life, whether we think of it as the ancient Greeks panspermia, or the use of free-floating life forces that converge in the universe as the triggering mechanism of life, or the aspect of parallel evolution coming from other cosmic oscillations, there is a very unique understanding here that is not the particles, but rather the greater energy fields responsible as the designing of the life process that has resulted in the Adamic or human creation. Thus, we have a very unique understanding that the human evolutionary process is not coming really from the immediate nexus of Mother Earth, but is really coming from the greater design of creation. In fact, Dan Burisch gives us, shall we say, a new interpretation of intelligent design, that is, higher forces of intelligence come together, whether we call these the autotrophic or the heterotrophic forces that are self-produced or behind the scenes working with the overall substances of creation. There is a higher purpose, a higher source of intelligence that is guiding these careful forces that have resulted in the DNA process we define as the beginning of life as we know it, the Homo universalis, universal humanity, that now stands before us as a reality that is not localized in our solar system, but throughout the whole universe. What I find fascinating in Dan Burisch's work is certain alignments and assumptions that he has made that are now proving true. In fact, this is what was also stated in my book, The Keys of Enoch, in 1973, that DNA can communicate if there are similar strands, even if they're not touching, even if proteins are not involved. There appears to be, as Dr. Baldwin and others have shown at Imperial College in London, in the tagging of DNA strands with fluorescence in water, that there is communication signaling that takes place. And this is very important because it suggests a paraphysical communication process between the DNA nucleotide arrangements that have similarities, even at the level of 1 nanometer in distance. And so it's suggesting that all things are part of an omnidirectionality of information sharing, that there is a much greater design in the whole evolutionary process. In fact, this is the larger design of the new physics, is the understanding of how a plasma field that is created in the Burisch concept of the physical sciences can create, as it were, the membrane for the bridge work through which evolutionary assemblage takes place more quickly, allowing for a whole new quantum state of creation. I find this to be most exciting. Again, there are great parallels with the Keys of Enoch, suggesting that we are on the brink of a fantastic breakthrough in the understanding of a whole new project genesis, of how we are being shown literally with our own eyes and ears in our scientific tools that we are co-participants in a great evolutionary discovery that has always been there, except we've had the wrong information, eyes, ears, and measuring stick, if you will. The process is the discovery of the inner bridge of the plasma forces. They connect all creation into new levels of growth.